Generally, there are two ways to determine the electrical power required for a fire pump. Firstly, the code-based method, and secondly, the pump datasheet method. The National Electrical Code, NEC, provides a simplified approach to estimate the electrical demand of a fire pump. NEC Article 695.1 states that the power required for a fire pump shall be calculated using the formula horsepower, HP, equals gallons per minute, GPM, times head in feet times specific gravity divided by 3,960. Use the horsepower value obtained from the formula to determine the electrical power in kilowatts. Kilowatts equals horsepower times 0.746. For example, if the fire pump requires 1,000 gallons per minute at a head of 150 feet, the electrical power required would be horsepower equals 1,000 gallons per minute times 150 feet times 1 divided by 3,960, which equals 37.87 horsepower. Kilowatts equals 37.87 horsepower times 0.746 equals 28.3 kilowatts. The pump datasheet method involves obtaining the electrical power requirement information directly from the pump's datasheet of the manufacturer. The pump's datasheet typically provides the following information: motor horsepower, motor voltage, motor current, power factor. Use the motor horsepower to calculate the electrical power required. Kilowatts equals horsepower times 0.746. For example, if the pump's motor has a horsepower rating of 40 horsepower, the electrical power required would be kilowatts equals 40 horsepower times 0.746 equals 29.8 kilowatts. In the scenario of an existing generator that has a capacity of 2 megawatts, which is 2,000 kilowatts, since the calculated electrical power required for the fire pump is 34 kilowatts, which is significantly lower than the generator's capacity, it is technically feasible to tap the feed side of the existing generator and feed a 250 amps magnetic breaker to the fire pump transfer panel. As for the location of the breaker, the NEC does not specifically require the breaker to be located in the generator house. However, for ease of access and maintenance, it is generally recommended to locate the breaker as close as possible to the generator. Here are some additional considerations. Firstly, NEC compliance ensures that the installation complies with all applicable sections of the NEC, including Articles 695 and 701. Secondly, generator capacity. Verify that the existing generator has sufficient capacity to handle the additional load of the fire pump. Thirdly, breaker rating. Select a magnetic breaker with an appropriate ampacity for the fire pump's electrical load. Fourthly, transfer switch. A transfer switch is required to automatically transfer the fire pump load to the generator during a power outage. Fifthly, panel labeling. Clearly label the fire pump transfer panel and breaker to indicate its intended purpose. It is always advisable to consult with a qualified electrician or electrical engineer to ensure that the fire pump installation meets all applicable codes and safety standards.